Brilliant, I'm up. A lot of conferences I attend, there's a very awkward moment where the speaker doesn't know whether they should start or not. That is definitely not the case at Devox here, is it? I feel like some kind of superhero after that intro. Anyway, thank you for taking the time to coming to this talk. We're going to be talking about scaling continuous delivery at large enterprises. I think everyone deserves to be commended for making it to the last talk of the day. It's a very long day. It's been a very fun day. And also because you've attended a talk without AI in the title, which is, not too common. Though, joking aside, I think I've enjoyed the practical theme throughout this conference of AI actually being used to build real things rather than the hype. So I've enjoyed the AI theme. We won't be talking about AI today, but I'll make one small consideration to it as I go through the talk. So AI is showing promise for increasing developer productivity. There's actually lots of studies that actually contradict that, but we are producing more code more quickly. And if we're putting more stuff through our continuous delivery pipelines, then the quality of those pipelines matter even more. And there's also a bit of a gold rush going on for people, very quickly adding generative AI-based features to all of their products, lots of startups, etc. So I'd say we're building more software than ever. So I think continuous delivery is still a very important topic. Anyway, jokes about AI aside, my name's Christopher Beatty. I've been a software engineer for the best part of 2 decades. The last 5 years or so, I've been focusing more on platform engineering, where I've been helping other people deliver software more quickly. So I used to be on the software engineering side. Now I'm more on the platform side, helping other people deliver software. Though, of course, platforms are also software, and all of the SDLC practices we have for software, we also apply for platforms. Everything I'm going to talk about today, it's really just my lessons learned, my experience from the last 15 or 20 years. It has been applied at small teams. So I've worked at startups where we've had one software engineering team, and at companies with over 1,000 developers and 200 teams, and everyone following the same continuous delivery pipeline. So I'm hoping you'll find something useful throughout all of that. There are many ways to implement continuous delivery. I know this way works, which is why I'm sharing it. I'm hoping it's going to be helpful for you. There are, of course, many other ways to do it. So there's many ways to do it. The focus of the talk is going to be on scale in many different ways. We're going to talk about all types of changes, software changes, vendor products, everything that makes up your production system. I'm going to introduce the concept of a path to production, which is what I often call like SDLC or continuous delivery, without any specific technology in mind. Hopefully one of the key takeaways from this talk is it does not matter what tool you use at all. You can implement effective continuous delivery with just about anything, and often we waste too much time focusing on which tool we're going to use. I'm going to introduce a few technical practices that have really helped me implement continuous delivery. Things like, isolated testing, stub testing, integrating early with realistic environments. And then the final takeaway, so the last bit of the talk, will be on a thing which you can do on Monday in your job. So if you resonate with any of the things I've talked about, what could you actually do on Monday to try and improve your continuous delivery process at your organization? So before we jump into it, let's have a shared understanding of what we think continuous delivery is. Here's my definition. It's pretty standard. So I think the goal of continuous delivery is to enable change, right? So we're not just talking about continuous deployment. We're talking about delivery at scale. So we want to do it fast. We want to do it with security built in, and we want to maintain or improve reliability. There's no point deploying things quickly if we're always breaking production. So if we dive into in a bit more detail, what are the types of change which you implement in your day job? Well, the most common one, and because this is JVM conference and it's mainly developers, and I saw how many hands went up in the keynote for like how many people are active Java developers. Well, a lot of the time that's code changes. It could be configuration changes. It could be new tests. It could be new monitoring and alerting, but it's for an application, perhaps accessed over some kind of queue or HTTP, gRPC, etc. Or you could be working in data pipelines or some kind of batch processing or some kind of data roles. The type of path to production I'm going to talk about today is equally as applicable for those types of things. I alluded to it already, but infrastructure, so we're talking about configuring network devices, provisioning things in the cloud, any of those enabling things which our applications run on top of. Again, exactly the same software delivery lifecycle process for infrastructure. And then I also include vendor products in that. So if you think about your holistic system, That is typically made up of lots of software you build, lots of things with data, definitely some infrastructure, but every so often your organization will choose to buy something rather than build it. And that makes up an important part of your system as well. And the approach I'm going to talk about today should be used for the vendor products you build as well. So we have the same levels of versioning, testing, promotion, etc., even for vendor products that we buy. And we touched on the characteristics of change. So if you want to scale continuous delivery at a large organization, speed is probably one of the primary motivating factors for doing so. But we're going to talk about how we build security into the pipelines and actually improve our security posture as we deliver more software, whereas the default can often be that the security gets worse and it's more of an afterthought. We're going to talk about reliability and testing strategies inside continuous delivery. We always want to assume the best, etc., but we have to build things. We have to build and expect failure. And then finally, if you're doing anything at a large organization, typically there needs to be a very good audit process in place. So what version of what is running in every environment, and how did it get there? So the two kind of takeaways so far for this is really that change isn't just about applications. And what I see, or certainly my experience, your experience may be different, is there's increasing resistance as we go down the line. So if you join a software engineering team, they're probably going to be following some pretty good continuous delivery practices. Data people, less so. Infrastructure, maybe. Vendor products, we often just install them and don't have any of our own custom tests, etc. But of course, every organization is differently. So this won't be the case everywhere. So change isn't just about applications, and something which took me a while to become confident in saying is there is no difference between software delivery lifecycle and infrastructure delivery lifecycle. We want to version things, we want to test things, we want to promote them across environments. So a recent change in certainly my engineering has been that I don't really distinguish between the two, but I think industry does. When we join an organization and there's a project which is deploying infrastructure, it's very unusual for everything to be versioned and tested and promoted. Not unheard of, though. Different types of scale. So I used to just think of scale as the number of engineers or the size of your system, and that's definitely one. But I think broadening your continuous delivery practices to those different types of delivery units, those different types of things that I talked about in the previous slide, I think that is a form of scale so that you can encompass your whole system. There is the size. So things become harder as your organization gets bigger. So size is really important. And then there's also industry. I spent a lot of time in the first 10 years of my career working in finance, and I used to think that, okay, if I've got this regulation, I need to do things differently. I don't think so anymore. I think the same principles apply. And actually, the way we interpret the regulations means that actually continuous delivery can help us more rather than less. Before I go into the solutions, I think it's good to talk about the problems, but I don't want to get everyone too down. So I'm going to talk about some of the problems which I've experienced when working at larger technology organizations. So the first one is, and I'm sure you've experienced this, is you go into an organization or you move between teams in an organization, and the departments actually feel like entirely different companies. They do absolutely everything different. They're completely autonomous. But the system that you're putting in front of your customer might actually be made up of applications built from multiple departments. So it makes it very hard to scale continuous delivery if everyone's doing everything differently. Specific examples of this is we might end up with customized security approaches. We might end up with different ways of working, delivery processes, work intake processes. I mean, just a show of hands, who here works at an organization that uses one CI/CD tool? Just one. So about a third, so that's not too bad. But even if you're using the same CI/CD tool, are all the pipelines the same? Or as you go between applications, everything's different? That kind of results in a very different level of quality as you move around an organization. Some teams are going to be really enthusiastic. They're going to have adopted lots of good practices around testing and promotion, etc. Whereas some people, it's manually executed tests on their machine, and then they go to production. Some of those more specific examples of how continuous delivery or delivery slows down at larger organizations. I feel like it's just death by 1,000 cuts, right? Unless someone's really championing for it. So we end up with lots of manual security tests. We end up with manual QA tests or functional tests. We end up with things, meetings and manual approvals and gating. As projects spin up and spin down, we end up with lots of different environments. We're typically building very large, complex systems that bring in like large amounts of open source software. So we've got licensing risks, we've got vulnerability risks. And as we decompose our systems into multiple, say, delivery units or components, or we move to more microservice-based architectures, we end up with a real large proliferation of environments. And then it's very unclear what set of environments are used for what for getting things into production. So if we want to speed up, say, our delivery process so the actual full system gets released once a day, etc., it can be quite a Herculean effort at lots of large organizations. Now, of course, change at large organizations typically means that you're going to have to deal with a lot of people. So this talk is specifically not about, small technical details of one CI/CD tool. But what we typically find at large organizations is we're going to have a change management team, right? And they're really going to focus on things like visibility and traceability and alignment. Depending on where your organization is at with removing silos and DevOps transformations, etc., you might have a completely separate operation team that is responsible for production, and they still care about stability and reliability and security, and they see change actually as a risk to those things rather than the benefit that it can be. And then we've got the development teams, who are basically pressured to produce features at the fastest rate they possibly could, when often not responsible for the service running in production. So they could have limited production responsibility. They may not be on first-line support. And it's very hard to be aligned with operations if you're not operating the software that you're building. But don't worry. It's not all bad news. I've talked about lots of problems. I think we work in a pretty amazing job, and technology can completely transform a business. So if you take a business that's releasing, once a month or once a quarter, like there was a great talk this morning about going from quarter releases to something like 300,000 releases a day or a week or something along those lines, is you completely transform that business. Like if you can put functionality in front of customers, months before you previously could, it's a pretty impactful thing you can do. And if you can take things like product launches from 6 months to 1 month, because we're not spending time generating custom CI/CD pipelines and manually provisioning environments, again, you can completely transform your business. So the approach I'm going to talk about now, which I call Path to Production as a Contract, is how you go about talking to your various stakeholders in your organization and getting a unified agreement of what it means for a change to enter production. And it starts, or at least for my idea, it starts with principles. So principles are a framework for making decisions. And I can tell you now that if you're trying to adopt or speed up delivery, there are going to be hundreds or thousands of decisions. And if you don't agree principles up front, then you can end up with decision paralysis and get nowhere. I'll make this much more concrete by giving you the principles that I used at the last big transformation I was involved with. So I'll turn that into an example. Then we agree a high-level contract. So we're not talking about very low-level pipelines here. We're talking about like a high-level contract that all of our different stakeholders can understand: change management, security, operations, and the development teams. We then talk about introducing technical practices that really help with continuous delivery. So you can have the perfect pipeline, you can have the agreement, etc. But the thing you actually do in the pipeline and the architecture of your application sitting in the pipeline also matters. So we'll talk about some technical practices. And one thing I'm going to really emphasize for the rest of the talk is that we need to measure throughout, and we need to measure at different levels to show the benefit to different stakeholders. And right at the end there, we might stick something in about tooling. And everyone needs an inspirational quote. This isn't very inspirational, but I think the death of any continuous delivery transformation starts with a tooling debate. My favorite's Argo, my favorite's Harness. I want to use Concourse, I want to use Jenkins. Maybe not many people say that anymore, but you know what I mean. And then we'll talk about push versus pull deployments, etc. But we haven't even agreed with anyone that we're going to try and speed up delivery yet. So you have to do your best not to talk about the tools, even though you need to implement the tool when you get to it. So what type of things do we measure during a continuous delivery transformation or trying to improve continuous delivery? Because if you don't measure, you often don't get credit for the benefit that you provide. So if you slowly, incrementally improve something, no one will know that you've improved it. They won't give you more buy-in to do wider changes, etc. There's something about a frog in hot water or something, which I'm sure I could talk about. But, what I'm trying to say is that we need to measure. And in my experience, there's only really 4 things that we measure. We do go into specifics of it, but we're either measuring speed, we're measuring something around performance or reliability, we're measuring security, or we're measuring some kind of cost, hopefully reduction in cost, or just greater cost visibility. One important reason to measure as well is it holds us accountable. I'm sure you've all worked on that project where you feel like you're working really hard to improve the SDLC process. You're adding functional tests, you've added versioning, etc. But the actual business can't release features any quicker. And I'll show you an example of this. So at my company, we have this concept of a needle. It's really just a measure, and we group them into a hierarchy. Because really just your business only cares about a few top-level things, right? So I'll give you a couple of examples. So if they're trying to launch a new product and the estimates are coming back as 12 months to build the infrastructure and the applications, etc., that's something I would want to measure. Is it 12 months? Can we make it 6 months? Can we make it 3 months? For an existing system, it's probably something about user-facing features, etc. Other key examples here would be the number of user-facing breaches, if it's a security-focused person, or the uptime, etc. Or for key events, how many times have we had an outage? So that's the level at which I would want to measure any kind of initiative. And then as we get down to the more technical people, we then start to measure things you probably recognize from things like DORA. So we'd measure things like lead time. How long does it take for a commit to get to production? How often do we deploy to certain environments? Those are very focused on delivery speed once you've got a commit. But if you're trying to increase the rate of delivery at a large organization, you probably care about other things like how long does it take an engineer to get their first change into production once joining a team. Or if you're starting to decompose your application into lots of services, or you're starting to build lots of new applications for whatever reason, you might want to measure how long it takes for a service to go from 0 to the smallest, thinner slice in production. So in all of that, it would be getting its environments, getting its infrastructure, getting its path to production, its pipeline, etc. And then there's a whole host of lower level metrics you could record under. Now, I'm not suggesting that you measure everything. So for each initiative in some time box period, I would want to, depending on what we're trying to achieve, I would make these specific. So I would say, okay, we're going to get to user-facing releases, 2 per week. We might be at 1 per month, etc. Those key features, to modify them, to add them, might really involve 3 applications. I've called them, X, Y, and Z. So then, because those are the applications we're going to focus on, we might decide that we need to get lead time, from 1 week to 1 day. So here we're getting much more specific. If we need security stakeholders on board, we might, during the same initiative, also say, reduce vulnerabilities in that stack from 35 to 5. And because we know we need to build a whole host of new services very soon, then we might want to reduce service onboarding from 2 weeks to 1 hour. So that's the importance of measurement. So before we start on any initiative, we want to measure and set targets for what we want to do. And then the next step is to set some principles. And these are 6 principles that have just worked for me, but I think it's very important to have them. So the first thing, which I always try and get agreement with, at least in a small nucleus of people, if not a wider range, is that we do need to consolidate the path to production. If we're going to scale continuous delivery across a large number of teams and a large organization, etc., we can't have everybody doing something differently. The second one is automatically generated pipelines, or whatever the path to production actually ends up being. And there's a subtle difference here between something being a service and automatically generated and being, say, a wiki page or Confluence or a template. I do not mean a template here, right? Because what happens to templates? People use the template and then they go out of date and they modify it and then we get a new version of the template. So for the path to production, I want some service which generates it and keeps them consistent across all of the applications. Now, put your developer hat on, because I know there's a lot of developers here. How does it make you feel to say someone else is going to generate the pipeline for your application? Because the default reaction is, people start to get resistant. No, my application is special. I need to do this. I want to use this build tool. I want to use this testing framework. I completely agree with you. I was an engineer on that side for a lot longer than I've been more of a platform engineer. So the third principle I especially want to get infrastructure people to agree with is that the path to production is going to have a flexible, light touch approach, which means that we generate the high-level steps of a path to production, but we leave it up to engineering teams and developers to decide what to put in those steps. So you use your build tool, use your test tool, etc. We're not going to be opinionated about that. There might be a separate technical initiative going on to stop us using 5 different build tools, but that's not this one. So we're not going to try and get people defensive by saying we're going to change their tool set. Teams responsible for quality. So what I mean by that is during a transformation where you want to speed up delivery, you typically want to make sure that people own services, they don't build artifacts. So what that means is that you're operationally responsible for the thing you build, and you really care about all of it. It's not just the code, it's not just the jar file, it's not just the Docker container, it's the thing running in a real environment. And it makes people care about observability and operability. That said, if you've got a more central team offering this capability, then the team's quality can be made visible by the platform. Things like some of those metrics I was talking about, like deployment frequency and lead time, this is an automatically generated pipeline that everyone's using. You can make those things visible, and it's extremely useful to see that across your whole organization. And I've actually got some examples of some tools that we built on top of CI/CD tools that that do that later in the talk. And definitely the most controversial thing, or certainly when I talk to people, is encapsulated component repositories, which is the lowest level technical thing on here. What I mean by that is if you want to deliver things to production quickly, everything required to deliver something to production needs to be in the same repository. We can't have the tests in this repository and the non-functional tests over here and the monitoring observability over here, etc. What we want to do is get the fastest possible feedback by deploying our real service into a real environment with the real monitoring observability right away. And we'll go into I'll show examples of that. So hopefully that kind of gives you an idea of the importance of agreeing a set of principles, because those principles will allow us to make lots of decisions. Because if we've agreed, say, on the principle of having a light touch approach, then we can short circuit any conversation about overriding the tool set of every single developer and saying they all have to do testing this way or etc. The next thing I would do is introduce the 2 stages of what I think makes up a really good path to production. So the first is fast feedback. I, as an engineer, want feedback on my change in a realistic environment as soon as possible. And I would go as far to say that if it's greater than 15 minutes, it's broken, right? And I'm going to talk about exactly the type of feedback that I would want as an engineer. That said, we have to be realistic. One of the companies where I really worked the longest on a pipeline just like this was a big streaming company, and they would stream NFL games. They would stream Premier League football games, etc. There is no way that they're going to allow a change to go to production if they only did 15 minutes of verification. So we need something in our pipeline, in our path to production contract, to allow for extended testing and validation. Our peak load tests, our key requirements around key events for our business. And we need shape for both, right? So we need the fast feedback for engineers, and then we need the extended testing for the safety and the criticality of the business. So let's get way more specific now, because all of that was a bit too abstract. So this is an example of a path to production. I've used a lot of different companies, and if I start a new company, I will probably just come and try and start a new company. I would just come and do the same thing. So this is the fast feedback part of the pipeline that I would want to agree with people. And it's only got 4 steps. So that is the level at which I want to get the agreement. I don't want to get an agreement with 15 steps with every single type of scanning and tooling and etc. I want to get broad agreement across lots of stakeholders that we're going to do build, that we're going to do stub functional testing, we're going to do stub non-functional testing, and we're going to build a fast integration environment. And I'm going to go through these one at a time to explain what I'd expect from every engineering team using this pipeline and why I think it's so important if you want to scale continuous delivery. So this is probably not a new concept to you, but the first thing that happens when you do a commit, say a merge a PR, but also you can do this on pull requests as well, is we want to build the software, right? We want to take the thing, which might be like a configuration file for a vendor product. It could be some code. It could be a bit of Terraform for some infrastructure change. And we want to turn it into a deployable, immutable, versioned artifact, right? Typically an OCI image. So the things that are mandatory in the build step are it outputs something which is immutable and versioned, and we put it somewhere, right? So that's all people are agreeing to. Now, of course, we want people to run unit tests. We want them to run linting. We want them to run things like vulnerability scanning, etc. But that's not in the contract yet because we're really focusing on adoption. And everyone can adopt build. Now, I talked about the light touch approach. What does this actually mean? Well, a typical implementation of this would be the pipeline would execute a build shell script or a make target or something like that in your repository, and then you as an application engineer are free to do what you like. You could use Maven, you could use Gradle, you could do the whole thing in make, you could do the whole thing in a shell script. That's what we mean about leaving the autonomy with the engineers, as long as they produce that artifact at the end of it. Once that passes, we have some level of confidence that the change is going to be good. It builds and we can run all of our localized tests. And that's the point that we published the versioned immutable artifact. Now, a typical implementation of this is an OCI registry where it's the container and manifests that can be used to run that. But it could be something else. And what we're saying at that point is we're ready for deployed service testing. So as part of any kind of improvement in continuous delivery, or any kind of DevOps transformation, etc., we are trying to reduce silos. We are trying to get everyone operationally responsible for the things they build, but give them better tools to do so. And one of the key ways of doing that is to say that as soon as possible, engineers get feedback for their service running in a realistic environment. And the first environment that happens in this contract is called stubbed functional testing. So by functional testing, I mean the black box business cases. So you're talking about you could implement them in the BDD framework where you're saying given, when, then. So it's so you're actually the functionality that your service requires. And this is by far the quickest way to verify your application because you can do it in isolation. So if your full system is made up of 30 microservices, we would not be deploying any of the other 29 microservices. We'd be deploying your decoupled, hopefully, microservice, and then we'd be running a test suite against it, and anytime it interacted with another service, it would be interacting with a stub. If that's not a bit of terminology that you're used to, we're going to go into the technical practices. But, it's an opportunity for us to verify our application very quickly, but also test all of the failure scenarios as well. Because the advantage of doing this in a stubbed manner is that we can prime stubs to inject failures like slow responses, etc. Now, the other thing which we insist on is a short non-functional requirements. Right? So it is much easier to gain confidence of your non-functional requirements in a non-integrated environment. I'm sure lots of people have experienced this, but if you have a large integrated stage environment and that's the only place you run performance tests, who here likes debugging why the latency's gone up or there's some problem, etc.? It is an absolute nightmare. So to get fast feedback, what I'd always want is a very short test to verify things like linear scalability, how I'd size the resources on my application, etc. And it is just a short run. Now, there are systems that there really are no non-functional requirements, or they're so small that it doesn't matter. So any of these stages could be a no-op, right? If there's actually an application which only gets 2 requests a second, you don't actually need to put something in the step. But we would see that, we'd have visibility, it would be a conscious decision. Rather than just not doing it, it would be this component doesn't need that and everyone's agreed to that. So there's still like a valid point in actually having it in the pipeline. The final fast feedback stage is fast integration or integration testing. So the word integration testing has many different meanings in our industry. In this context, all I mean is it's the first time where your application talks to other applications. Right, so if you've got lots of microservices, this is the first environment where you'll actually deploy them and they'll communicate with each other. If you have an existing integration environment that is never up, it's always broken, and the tests never pass, this is not it. What we do is slowly build a reliable integrated test environment. So as people get more mature and they catch all of their issues in the stubbed functional test environment, we'd add components to this integrated test environment and we treat it like production. We deploy our monitoring and alerting here, etc. We'd build a culture where anyone can run a test at any time, and each test manages its own data lifecycle. So I'm not talking about any type of integrated environment where you need to coordinate, with Trevor, who owns the SIT6 environment, and you can run a test between 1 a.m. and 2 a.m., and then you can't get another slot for another 2 weeks. So that is the integrated test environment, and I'd say it's pretty much, if not the hardest, the second hardest environment to get right. But it gives you confidence very quickly that all of the assumptions you've made in your stub tests are actually valid. So we do want to integrate soon. And picking the point of integration in a large system for continuous delivery, I think, is one of the hardest choices. By that point, that's the 15-minute point that I talked about before, right? So all of that happens in 15 minutes, which again heavily relies on the fact that you do most of your verification in your stub functional. In a mature continuous delivery setup, so after you've worked on this for probably many years at your organization, every single issue, or 99.99% of issues that you're going to find in fast feedback, right? Anytime you have an issue later in production, heaven forbid, or in one of the extended environments that I'm going to talk about next, we attempt and we build a culture of backporting a reproducer into one of these three test phases, and we do our very best to make it stubbed functional all of the time because those are the easiest tests to write. But I said before, a lot of businesses will not allow their critical systems to be deployed with 15 minutes of verification. So the other stage, and this will depend heavily on your target release frequency in production. I'm doing an example here where the target was once a day, right? It could be twice a day, it could be 10 times a day, it could be every commit. The premise that I'm doing this under is that we want to do expensive extended verification. So the company I was actually at is we actually did a 16-hour performance test before any release to production. So we obviously can't do it for every commit, right? So we would do it once a day, and it would take the latest version of each component that had passed fast feedback and then run the tests. Two types of tests that could go into this phase. Again, there is definitely a big use case for having extended stubbed non-functional tests. So it's exactly the same as the previous step. You can just run longer tests. And then the other type, which is definitely the hardest environment to get right in continuous delivery, is an extended integration test. So if you are an organization where you're really beholden to needing these longer integrated tests where you put your whole system together, this is the environment that you would need to do it in. That said, what you want to do is build confidence in your organization that you don't need it. So if we get to the point that we never find issues in this extended integration and test environment because we keep backporting fixes and improving the maturity of fast feedback, then eventually we might omit the need for this one. The final stage of any path to production contract, obviously, is getting it into production. Highly, highly, highly recommend having a way to stage your changes to a subset of your customers. Everything up until now has been about preventing known problems because it's been test-based verification. You've written a functional test, you've written a non-functional test. You can't predict everything, right? Things are actually going to go wrong in production. And being able to release changes to a subset of your customers is the best way that you can reduce the blast radius of any unexpected problem. So the other thing that we include in a contract is the concept of some kind of canary rollout. And then the importance becomes, how do you move between a canary and a production release? And this goes back to the principles of the quality. The team is responsible for the quality, but the system, the platform, can make that quality visible. And one of the key interfaces that I like is that every single application is responsible for producing metrics to gate promotions from canary to production, where they think about how that component is actually used for key business use cases, and they either produce some like system health metrics or business health metrics. And then there's an automated process which looks at those metrics, or you have defined alerts based on those metrics, and that decides whether a canary release becomes a production release. And of course, because we're getting standardization, another benefit of this is this can all integrate with your change management system, assuming you have one, right? So if you have something like ServiceNow, etc., many ways you can integrate it. So you can leave in manual promotions for now if you need to, but as people improve the maturity of those steps, we start to introduce automatic change requests, which can then get the evidence from each of the steps and automatically put it on the change request, etc. Obviously, these things can integrate with freeze windows, etc. So you can that's going to build a lot of confidence with your change management stakeholders. So that was quite a lot to cover. So we've seen an example of what I mean by a path to production contract. But it sounds like a lot, but really all I'm trying to do is to get a group of people to agree to 4 different things, right? Build something immutable that's going to give you confidence that the same thing is going through all of the environments. Promote developer fast feedback and engineer fast feedback. Provide a mechanism to run extended verification. There might be no business justification for doing anything in that extended verification for some components. So there's nothing wrong with a no-op and the platform making it visible that there is a no-op for that component. And then finally, we need a way to roll out changes gradually in production. So those are the 4 points that I want you to take away and think about how they'd apply to your continuous delivery pipelines. The next thing I want to show is some of the cool things that you can build on top of consolidation. Right? If everyone uses a separate path to production, a different pipeline shape, etc., nothing's common, no one versions the same way, you can't do things like I'm about to show you. So this is an example UI that we built on top of a other CI/CD tooling. Is it big? Yes, it's definitely big enough. So really all it's shown, and I've made up some of the names just so I'm not leaking the company's application names, but it's like a service catalog you would see in something like Backstage, but way more useful in my opinion, because it's got the application name, it's got the team name, but then it's also got the version that is in each of those environments that has passed those quality gates. And then it's actually got links, to go and find the execution of that step. And the only thing we've really done consolidated on to be able to build this is the pipeline shape and the fact everyone is using the same tool. But you don't even need the latter. So I have one project where there was a large migration from Jenkins to GitHub Actions, and a tool like this could actually query both because they were following the same contract. They were just doing a tooling update. This same tool, for instance, can drill down, and it's a very, very easy tool to build. So this is like a real-life version of this path to production contract, where you can see the steps, you can see whether they've passed, etc. You can see the versions flow through your system. And all this is doing is querying 2 things. Because the underlying tool was GitHub Actions, it's querying the GitHub API. And because those deployable immutable version artifacts, that's a DIVA, I should just say DIVA. Because those DIVAs were in OCI registries, we can query the version information, and it's as simple as that. Now, this for me is just amazing because imagine engineer onboarding time, right? If you join a new team and you go to this UI, you see which applications you're responsible for. You can see what versions are running in what environments. There's even some extra links here where it clicks you down to the GitHub repo with the pipeline, etc. There's actually extra links here which actually take you to observability, etc. of it, etc. And views like this, which aren't that hard to build once you've got the consolidation, they build lots of confidence with stakeholders like change management. So you're not bringing them a Confluence page, you're not bringing them a large report which you're attaching to some ticket in ServiceNow. You're just opening this up. And if they want to see then what each team is doing, they can just click on the links. So really what we're doing here is we're giving people an opportunity to know where to look. So I can go to any application in my team or in my department and just go and look at what they do for functional testing, non-functional testing. But the engineering teams still get their autonomy, right? They can still do it. They can still do it differently. So the next thing I want to talk about are some technical practices which have helped actually improve, I'd say, the maturity of some of these steps. So assuming someone's doing the steps, how do you help them make them do the step well? So the first one I want to talk about is stubbing. So I'll go into a little bit more detail about that. Now, I think stubbing is the unsung hero of continuous delivery, and I'm still shocked, like when I deal with new engineering teams and they do the majority of the verification of their system in a fully integrated way. So what we mean by stubbing, and I think like a critical technique that underpins kind of continuous delivery, is to be able to verify the components in isolation. And that's what stubbing allows us to do. It allows us to simulate failures. And it's the only pragmatic, realistic way that I know, and please tell me if there are more, of running hundreds and hundreds of functional tests under that 15-minute period that I was looking for. So let's go through an example of what this means. So the first thing is, I'm going to couple in deploying your service in a realistic environment, is we have realistic environments for the stages of our path to production. That might not be something which you've got at your organization, and you should talk to your platform team and ask for it. Because I do think a prerequisite to being able to move fast is to have realistic environments you can do your verification in. That said, there are workarounds. You can do testing on CI agents, or whatever. So we already know that we've packaged the application into a DIVA, into a deployable, immutable versioned artifact. And then we're going to use that to deploy it. So imagine you've got a service which streams television. It's got a couple of backing services. So it could be, a Postgres, a Kafka. So we're not stubbing those out. Right, so those things are real. They might not be the fully fledged, expensive, scaled version you're using in production. They might just be deployed as a container. The important thing is to say there are no other delivery units, and delivery units is the phrase I'm using just to describe any of those units of change, right? Be it an application, pipeline, bit of infrastructure, or vendor product. And then we deploy stubs. So all I mean by a stub is something that can pretend to be something, right? The most common things that we want to stub are things like HTTP or gRPC. It's your inter-service communication. But as far as this playout microservice is concerned, it's going to be talking to the real things. And then what we want to do is, through our stub, prime it to behave like the real system, the other applications that we interact with. So we need that bit of functionality. Send a request in. That request, again, could be a message on a queue. It could be gRPC. It could be HTTP. And then we want to verify the responses. And this, for me, is the fastest way to get verification and to give confidence so we never break the integrated test environment. Because if you break either of the integrated test environments in a continuous delivery setup, I think you're destined never to release software very quickly. The other kind of point that I've been touching on is I would do nearly all of my testing in a realistic environment. So one thing I used to optimize for when I was a software engineer on the application side, 10 or 15 years ago, was not relying on my infrastructure for my testing. Why? Because it often wasn't there. I couldn't get the infrastructure. I had to raise tickets to get the infrastructure, etc. So I put a lot of effort into being able to run everything locally, be able to run on the most generic, say, Linux CI agent, because I didn't trust the infrastructure. But I think we're past that now. I think lightweight, ephemeral test environments for continuous delivery is becoming a commodity, and we should just all have it, etc. So assuming that we have that, then I want to test my application and find every type of problem early. Let's take an example. A microservice packaged as a container with some Kubernetes manifests, some dashboards to help you monitor and alert it, etc. I would actually deploy that thing with the real manifests, with the real monitoring, and make sure the whole thing works. Everything that I've talked about up until now, because we've been stubbing, apart from that integration test environment, has been an instance of a path to production per application or per delivery unit if we're talking generically across the 4 different types. I just want to talk about one kind of mishap that I've made a few times in my career, which can kind of derail any kind of continuous delivery transformation. So any instance of a path to production in the ways I've described it, should be completely decoupled. If you ever have to coordinate, the running of those path to productions, then things aren't going to go very fast. And like the use case which we're often working with is we've got an existing system. It might be deployed very infrequently, say quarterly, and then we stay up on 10 p.m. on a Friday night and we deploy the whole thing together. So it is not a loosely coupled set of services. It's actually a very tightly coupled set of services, even if it's distributed at all. So let's have a look at an example of that. So we'll stick with the example of building, say, a TV streaming service. Well, that's going to have, some client applications. It's going to have some load balancing layer or GLB or something. But essentially, the client applications are going to talk into a whole host of other services that have been separated into separate processes for whatever reason. So we've got the auth service, we've got the playout service, and we've got the favorite service. One mistake I've made in the past is that I have taken each of those processes and given them their own path to production because it makes sense to me. They're a separate service, perhaps they're a separate Java process, etc. But that suddenly means that then I can't release them independently because they haven't been designed to be loosely coupled. So let's say the auth service, the favorite service, and the playout service in this example have always been released together. It's very unlikely that they've got backward and forward compatible APIs and they think about API versioning, etc. So when I'm starting from an existing system, which is tightly coupled and deployed together, what I'm looking for is pools of different services that I can work out that are loosely coupled. And then I'm going to put a path to production for each of those groups. And I'm probably going to only go back and retrospectively separate them out if I have the time to re-architect them to be loosely coupled. So just to kind of summarize all of that, service encapsulation, that means that everything that's required to deploy a service needs to be in one place. If you're having to coordinate between teams, repos, etc., for where the tests are, where the configuration is, etc., you're gonna struggle. Have its own pipeline. That pipeline will be consolidated. Everything has its own monitoring and alerting, and we use it as soon as possible. And no coordination. Everything needs to be deployed independently. Whew. So that's a lot, right? And if you're thinking to yourself, I deploy once a month, what on earth am I going to do? And I think there are two high-level approaches which I take to actually starting any kind of change, right? I'm going to call them top-down and bottom-up. Or another name for that is like leading from the front or leading from the back. So sometimes you might be in the enviable or maybe unenviable position of actually leading some kind of, dev improvement, of continuous delivery improvement, and you're completely accountable for it, right? So we're going to start with that case first. So you've got a lot of responsibility. So the first thing I would do is go and talk to each of the stakeholders, change management, security, operations, whoever's involved, and understand their problems, right? Never go to them and talk to them about pipelines and consolidated pipelines and fancy CI/CD tools, right? Work out their problems. My theory is that most people's problems in engineering fall into one of those categories. That is, it's either speed, it's either reliability, it's security, or it is cost. You then come up with a quantifiable improvement. So everyone's got problems. Most people love to tell you about their problems, but you need to turn it into some number so then you can action it. And then you end up with you agree the top level needle to move, and then you use your engineering skills to work out which needles to move underneath, right? So the example before was, we want to increase number of customer facing feature deliveries to 2 per week. We need to probably improve these components, lead time, etc. Now, often, especially as a day-to-day engineer, you do not get buy-in to suddenly set up lots of workshops and meetings with all of the head of infrastructure and the head of change and the head of in your organization. So the other one is bottom-up. So here, I'd say, unless you want to prove a technical approach, do not start with some service that no one cares about. Identify an actual business journey that people don't like. So what other people think is rubbish, you want to go and find, and that's the thing you're going to go and improve. Then you would find the components of that service. So for those user journeys which maybe suck and everyone complains about, work out which components. Alternatively, you could start from the components and then go to the user journeys, etc., if you know which ones you're responsible and have the remit to change. Then do a very quick evaluation of the current maturity. And I've got a little tool which is free, which we're going to be free to use, which you can do that. And then you end up at the same point. Based on looking at the continuous delivery maturity of a few of those key components, which make up a really important business user journey, you work out like which needles you're going to move. Because you're doing this bottom up, right? You're not really asking anyone to do this. You're just doing small technical improvements. It's the same way that we often introduce a small tech deck task, or tax is what I'd say, on feature delivery. If we know the code base sucks, we know it takes longer to implement a feature, so our estimates are bigger. Well, I would say it's the same thing. If you know the maturity of the path to production of the component that you're working on sucks, your estimates get bigger. And then you use that to introduce small changes, but you need to end up quantifying the improvement. Otherwise, you never get credit for it, and you'll never be able to go to the top down. In reality, if you can do both, do it. Right? No one cares about the top down if nothing actually happens, and the best way to get buy-in from people when you're doing top down with the actual engineers is also to do the bottom up, so you actually understand the systems that you're talking about rather than just talking about change. So one thing I'm about to put on our website, which will be free to use because it's basically the encoding of our experience. I've just put a few screenshots. I was hoping to get this released before this conference, but it will be out in like a week or two. Is basically a tool for answering lots of questions about a delivery unit, a thing, and then it's spitting out some numbers to say, okay, these are the things that you should probably work on. And it's exactly the thing I've just taken you through, right? So first, there's some basic information, like what type of capability is it, just so you understand. Is it a bit of infrastructure? Is it an application with some code? How is it hosted? Then we go on to the build step, hopefully sounding very familiar. We see, like, do they use trunk-based development? Is it using something like Git flow? Is it versioned, etc.? Is there linting, unit testing? Do people actually fix the build if it's broken? You probably need to change that. And then the same, we just go through the steps of the path to production. So then there's lots of questions to see, do developers actually get fast feedback, or are things kind of just like left for a day or two, and then someone finds out that they're broken? So it's just a tool which will go through that, and at the end, you end up with this, right? So for that key user journey, you end up with these are the components. I've answered the questions. It's about 15 minutes. It takes me, if I actually understand the component, probably an hour with someone who understands the component if they need to walk me through. And then it gives you kind of a maturity, which will then give you a plan, right? If you know you need to improve reliability or speed, etc., this is the type of data which helps me decide what to do, because when you're trying to improve stuff, the hardest thing is often deciding what to do first. This isn't quite out yet, but it will be within a week or two. I created a QR code that if you want an email when I do release it, you can sign up there. I promise I will not email you anything else, so don't worry. Feel free to grab that. I've got it on the last slide as well, so don't feel like you have to grab it right now. So that's everything. So I think key takeaways, in case you fell asleep, because it is the last talk of the day. Continuous delivery transformation can happen top down and bottom up. So don't feel like it's all lost if you don't have the top down permission. Ideally, you can do both, or if you start bottom up, you can then do top down, but don't stop doing bottom up. Measurement is a good way to translate the benefit of continuous delivery to people who aren't application developers who really love continuous delivery, right? So when you're trying to improve things, measure it in terms of what's the benefit for security, what's the benefit for operations, etc., what's the benefits of change management. Agreeing a small number of steps that everyone does is way more valuable than picking a tool and rolling out a tool that no one uses or people use inconsistently. And in my experience, the only way to get engineers to actually adopt this stuff is to keep it lightweight, preserve their autonomy. And on that note, thank you very much. If you want to connect with me on LinkedIn, here's the QR code for that. So I actually don't have the other QR code. I completely lied. This is a different QR code. But I like talking about this stuff. If you see me at the conference and want to talk about continuous delivery, I love talking about it. Not really anything else. I don't have any other interests. And on that note, thank you very much for listening. Cheers.